Hello and good day, Algebra. We are covering CO37, interpreting a scatter plot on the heels of creating one that we made in CO36, which compared the points scored for each team during this past NFL season compared to the games that they won. And the relationship that we found, not surprisingly, was the more points a team scored, the more games they generally won. And what we talked about was what type of relationship that shows. More points scored, more games won. In the scatter plot realm, another word for relationship is correlation. How something correlates to something else. Okay? How strongly it causes something else to happen. So a positive correlation, like we saw in our scatter plot, will have a line of best fit that looks kind of like that. Okay? It'll be going up from left to right as our line of best fit did. And it means that as X is increasing, Y is increasing as well. Okay? As more points were scored, which was our x-axis, more games were won, which was our y-axis. That represents a positive correlation between points scored and games won. Okay? A negative correlation is going to be going down from left to right. And it's not what you might think. A lot of folks might make the jump to say that as x decreases, y decreases. Actually, X is still going to be increasing here. So as X increases, Y now is going to decrease. Okay, so for a negative correlation, X will still be increasing, but Y is going to be decreasing. Because think about it, if both values were decreasing, if the number of points decreases, games are decreasing, well, that kind of is the same thing as we said with our positive correlation, right? If one goes up, the other one goes up, then it makes sense that as one goes down, the other one goes down as well. So just like how in other situations in math, a negative and a negative make a positive, it's kind of the same thing here. Both can't be decreasing for a negative correlation because that actually represents something positive. Okay? So an example of a negative correlation might be temperature and hot chocolate sales, right? As temperature goes up, hot chocolate sales will typically go down, okay? Can anyone else think of an example of a negative correlation? As one data goes up, it causes another one to go down. Emily?
Summer and ice cream.
Summer and ice cream. That actually, well, when you say summer, what's the data that you're tracking in summer? Just as summer drolls on? I might actually argue that would be a positive correlation. As summer continues, it typically gets hotter, right? From June to July. August is kind of the hottest month. Ice cream sales would probably go up. Anyone have any other possible negative correlations? Well, we'll get to some then. Okay, we'll get to some. And then the third type, no correlation. The scatter plot is going to look more or less like this, where there's no real line of best fit that can be made there because they're all just scattered everywhere. There is no relationship between the two things that we are comparing. Okay? What would an example be of two things that have nothing to do with each other? Gabby? Sure. Well, okay. Yeah, I'm not going to get too technical. Yes, what you eat for breakfast in the morning in a test grade, whether you have sunny side up eggs or Wheaties or a Snickers bar, last night's pizza. I don't know if there'd be. You're right. Not all that influence on a test grade. How well you do in school and sports you play? Yeah. Okay. There might be a connection between how well you do in school and the number of sports you play if maybe your just time management isn't great. But generally, okay, I can get on board.
Mr. Schultz's button and the amount of time that class period lasts.
Mrs. Schultz's what?
Your button.
Oh, my button and the amount of time the class period lasts. Yes. Today I am sporting the Pen Pineapple Apple Pen button, if you are familiar with that. And now it'll be stuck in your head if you know what I'm talking about for the next 2 hours. Any other negative or any other no correlation examples that you want to bring up? Okay, so what we're going to be doing today then is looking at various scatter plots, deciding what correlation exists, if any, what conclusion can be made, if any, and then answering perhaps a follow-up question. So let's scroll down to our homework part here. Oops. Our first one is the number of missed classes and exam score. First of all, what type of correlation is this? Positive, negative, or none? Elise? Negative. Our line of best fit is going down from left to right. As the number of missed classes increase, the exam score decreases. Okay, so it is a negative correlation. Kind of a connection with slope, right? Positive slope is slope that goes up from left to right. Negative slope is slope that goes down from left to right. Same kind of thing here, because what direction we read a graph? Left to right. Okay, so there's that connection there. And what conclusion can be made from this? Oh, the next one, yes. Well, yeah, Brent.
The more missed classes, the lower the exam score.
Right. The more you miss class, the lower your exam score is going to be. Is that true for everybody? You know, we do have some outliers here, some that are kind of far away from the data. Not a very great test score, but didn't miss as many classes as other people. I want to see who's missing like 28 days of class here. Said by the teacher who missed 16 days in a row. Never mind. Okay. I walked into that one. That's my own fault. Yeah. Next one here, shoe size and IQ. What type of correlation, Lucas? No correlation exists here. It's all over the place. I'm just realizing I've taught this this lesson several times. I'm just how ridiculous this chart is to begin with. I've never really looked at the data before, the actual numbers. I mean, oof, that's not good. That's not good. Yeah. Considering the average IQ is 100, that's, anyway, okay. So, no correlation can be made there. Next two here. We've got age versus video games. Age is across the bottom. Daily amount of video games in minutes. Our y-axis, what type of correlation and what conclusion? Soybean. Negative correlation. Our line of best fit is going down from left to right. And what conclusion can you make about this? Lucas. Okay. The older you get, the less time you spend playing video games. Unless you're 36 and just got Mario Maker 2, in which case, you know, we're... there we go. Okay. And then the follow-up question here, you know, we can use this to kind of get that general idea. We can also dig in for more specific. Did anyone age 30 play 30 minutes of games? What are we looking for to answer that question? Anyone age 30 play 30 minutes of games? Gabby? Exactly. Age 30, you know, that's our X. Minutes of games, that's our Y. So we're looking for the order pair 30, 30. Copyright ESPN. Okay. So 30, 30. Was there a point there? No. So did anyone age 30 in this study play 30 minutes of games? No. Okay. Yes?
Yes, because someone 30 they play 60 minutes of video games. And yes, that's 30 times 2, but it's still 30.
Right. So the better way to ask that question, if that's what you're going for, is anyone play at least 30? You know, the way this question is phrased, did anyone age 30 play 30 minutes? What Lucas is saying is that, you know, there are people age 30 who played 60 and 75 minutes. So technically they did also play 30 because they had to play 30 to get to 60. But the way this is worded is asking for the specific 30, 30. If it was at least 30, then the answer would be yes, because you've got some points there. Okay. The next one. This one is notoriously horribly copied on your page. Can you read what it says? Age and now. Okay, so the x-axis here is age, and the y-axis is hours. The age values start at 0, and they count up by 2s, and the largest x value where there's data is 20. So 0, 2, 4, 6, 8, all the way up to 20. Your y-axis starts at 7, actually, and the largest number for which there's data is 15. So that starts at 7, count by 1s, get to 15. The x-axis start at 0, count by 2s, out to 20. And no legend here for the graph, so we don't really know for sure what it's referring to. Thus the question, what could this scatter plot represent? What is a situation that would fit the data that we would get here? Gabby, what do you think?
Hours of free time as you get older.
Hours of free time as you get older, okay? When you're a 2-year-old, 15 hours of free time, yeah, what else you got to do, right? You just got to sleep and eat and play with this and point at that and cry, and yeah, the world's your oyster. When you get to be, your age here, 12, 14, 16, this would be 9 hours of free time. That's actually not too bad there. But then as you get older, yeah, you have more responsibilities. Maybe you pick up a job, you got chores to do at home, homework, whatever else. Erica.
How much sleep you get.
How much sleep you get. Okay, that's another good option here. When you're a baby, toddler, sleeping 14, 15 hours a day, not unheard of. When you're teenager and adults, based on your math packet results from a couple of weeks ago, you folks are more, down in this range, or maybe some of you down that range there. But yeah, hours of sleep you get. As you get older, you need less sleep. You get less sleep. So that's another option. Okay. Any others? Peace? Does that mean like no?
No.
It doesn't mean no?
Peas.
Oh, peas. Number of peas eaten as you get older. Yes, maybe. Toddlers love their peas, but then when you're an adult, you eat less. Brilliant. That's very good. Okay. All right. Yes, Soybe?
Maybe it's like the older you get, the less candy, and the younger you are, like more candy you eat. So
Candy. I eat a lot of candy. This graph would not match my diet, so, but possible. Okay. Then the next page, we've got a couple more here. This one, time spent studying, student grades. What's the correlation? What's the conclusion? The next one, Mrs. Johnson's second grade at Smith Elementary School. We've got the Iowa Skills Iowa Assessment Score and the Iowa Reading Score. And the question here is, how many students are in Mrs. Johnson's class? This is a type of question we haven't talked about yet. How would you figure it out? Count the points, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Does anybody have a caveat to that? Do we know for certain that there are 20 students in Mrs. Johnson's class, Brent?
No.
Why not?
It doesn't say like the kids. It could be the kids take the test twice in a year, and it's like 10 kids in the class.
Okay, so we don't know if each dot represents just one kid's highest score or if they take it more than once. So one student could be represented more than once on the scatter plot. What else? Julia? It's possible that 2 students get the exact same score on both assessments, and therefore one dot would actually represent 2 students. So that's possible too. Okay? Is 20 probably pretty accurate? Yes, right? But we don't know for sure because the scatter plot only plots the data, and if 1 point represents 2 people because they got the same score, we don't know that here. Okay, so I would accept 20 with the caveat that we don't know for sure. Not my first rodeo, friend. Okay. Yes.
So would you put something like about 20?
About 20, yeah, or 20, but we can't know for sure. Okay, I'm making kind of a big deal about this question because there's one like it on the test. Hint, hint. Okay, so we can count the points, but we don't know for sure how many students were studied. Okay. Then the bottom three, you get to kind of put on your creative hats and give me an example of what each scatter plot below could represent. We've got one with positive correlation, one with negative, and one with none. Don't pay attention to the data points here. You don't need to try and pick something to match those. You can kind of come up with anything you want there. If you want to use them, great, but you don't have to. Questions on this?
No, thank you.
All right. This is due tomorrow, and if that's all you've got for me, that's all I've got for you. Don't forget to like and subscribe, and have a great day.